Hi everyone, welcome back to our CSEC Quadratics course. Alright, so last we started to talk about what is a quadratic, a curve, right? So we noticed that the name of the curve of a quadratic is a parabola. A parabola takes this kind of U shape, right? It's more like a V-shaped curve with more at a rounded base or a rounded top. Yeah. So it doesn't actually be a V. It's kind of like a V, right? But instead you round the curve here, or it's an inverted V, what you call a bell-shaped curve, and you also round the top here, right? So your quadratic curve, which is called a parabola, could look like this, which is what we call a minimum point graph, or this, which is what we call a maximum point graph, right? So in case you want some clarification, feel free to go back to the last video, which was session 12, I believe. So this is that's session 13. So this is session 14 now. All right, so we want to continue just a few examples on identifying the important points from a quadratic because we want to learn how to actually sketch these curves. But to sketch these curves, you need to know certain things from the curve. So the first thing that you need to know is what we call the nature of the minimum point. The nature, sorry, of the vertex. So the vertex is either the lowest point or the highest point depending on the type of the curve. So in this case, the nature of this vertex is minimum. All right, so let's put min here. Just want to save some space, right? The nature, because this is a minimum point curve, so we call it a minimum point graph. So the nature of the vertex is that it is a minimum point vertex. The second one, and this is in no particular order, right? The second one, you want to get the coordinates of the vertex, right? So the coordinates of this point, remember, you take your x value first, which is -3 in this case, and your y value here is -6. So -3, -6. Now the coordinates of the vertex. Next one now, we want the coordinates of the y-intercept, right? Now the coordinates of the y-intercept, this is where the graph cuts the y-axis. The y value where the graph cuts the y-axis is 5, right? Which means that the x value, because it is on the y-axis, this one is on the y-axis, the x value is 0. So the coordinates of a y-intercept is always 0, 5. Right? The fourth one now, I'm going to put this one right here. The fourth one that we want to be able to identify are the coordinates of the roots. Right now, from the last video, we would have learned what the roots are. The roots are where the graph cuts the x-axis. So in this case, I'm going to write it here. The roots are x is equal to -5 and x is equal to -1. These are the roots. But the coordinates of the roots, remember, on the x-axis, y is 0. So the coordinates of these roots are -5, 0, and -1, 0. Right? And the last thing that we usually do is that we want to find what we call the axis of symmetry. So imagine, remember, a line of symmetry is a line that divides a shape into equal parts. So an axis of symmetry will do the same. So this axis of symmetry passes through the x-axis at -3. So we want the equation of the axis of symmetry, right? And this is very easy. It is just x is equal to whatever is the x value of the minimum point. X is equal to -3. Yeah. So we just want to be able to identify these things for these graphs here. All right. So let's go again with this one now. All right. So we're fitting this one here on this side. All right. Feel free to pause the video anytime if you want to go over or if you want to try out each one on your own before I give the solution. You can go ahead and pause. Right. So this one here now. Oops. All right. So let's see about this one now. Same thing with this one here. We want to get the nature. All right. So remember the nature of the vertex is what type of vertex it is. It is a maximum point or minimum point. This graph is clearly a maximum point graph because it has a highest point, right? The second one is the coordinates of the vertex, right? What are the coordinates of the vertex? the x value of the vertex is 4 and the y value is 5. So the coordinates of the vertex in this case is 4, 5. All right, this is 4 over here. All right, next one now, number 3. The coordinates of the y-intercept. Coordinates of y-intercept. So, if we notice, the graph passes through the y-axis at what we call the origin. That is, x is equal to 0 and y is equal to 0. Number 4 is coordinates of the roots. Coordinates of the roots. So first of all, let's write down the roots. So where does a graph pass through the x-axis? Right, the roots are x, the graph passes through the x-axis at 0, x is equal to 0, and it also passes through at x is equal to 8. So that's the roots of this graph. So the coordinates of these roots are where the graph passes through the x-axis and y-axis. So the coordinates of the roots are x is 0, y is 0, and x is 8, and on the x-axis y is 0. And the last one now is the axis of symmetry. Axis of symmetry. Right, again, it is just a line that cuts the graph in half. So that is at this point here where x is equal to 4. The line passes through the x-axis. It's a vertical line passing through the x-axis, so we call it x is equal to 4. Now there's one more thing that you need to know, but mostly for add maths, but it also comes in maths, which is called the minimum value. We will get to that in a short while, right? Not right now. So let's go now into this one here now. Right, again, we want to go through the same things that we had above here and see if it is we could get them. Right, so the first one, if you want to pause the video here and try to do it for yourself before I give the answer. So feel free to pause the video, write it down in your own notes, and then try it for yourself. Right, so welcome back now, and let's see if you got the answers correct. So the first thing we want to look for is the type of the type of vertex, or what we call the nature of the vertex. Nature of vertex. Right, what type of vertex this is? This has a lowest point, so it is what we call a minimum point graph. The second thing, and again is in no particular order, we want to find the coordinates of the vertex. In this case, the vertex is a minimum point. So what is the coordinates? So look at where the lowest point is here. This is the lowest point. Yeah. So the lowest point is where x is -7, but it's touching the x-axis. So don't forget, on the x-axis, y is always equal to 0. And similarly, on the y-axis, x is always equal to 0. So the coordinates of the vertex is -7. And since it is on the x-axis, the y value is 0. Number 3, we want the coordinates of the y-intercept. So the y-intercept is at y is 10, right? So the y-intercept is equal to 10. So if they ask you for the y-intercept, they don't want coordinates up. The y-intercept is just the y value, but the coordinates is both the x and y value. But the y-intercept is on the y-axis. So the x value is 0 and the y value is 10 in this case. Number 4, we want the coordinates of the roots. Right, so what are the roots? The roots are where the graph cuts the x-axis. So this one is a special type of graph. In this one here, the graph only touches the x-axis at one point. So I'll write down something here about that in a little bit. But the coordinates of the root, in this case, you have only one root, is -7. And on the x-axis, y is 0. So -7, 0. And the last one now is the axis of symmetry. What is the equation of that line that cuts the graph in half? If I just draw my symmetry line here, you notice it passes through x is equal to 7. So that is the axis of symmetry. Sorry, x is equal to -7. Yeah, a nice way. These are things that are very easy, and I'm going through each one of them in detail with you. Now, a little side note here, right? I'm gonna put this in a different color. So note, if the graph touches the x-axis at one point, right? Since the graph touches the x-axis, at only one point, there is only one root, right? But the graph is said to be tangent. The graph is said to be tangent to the x-axis. So this is just a fancy way to say that something is touching something else at one point. Yeah. So it's just touching it and is not cutting through, not passing through the axis. Right? It's just touching it at one point. Right? So when something is tangent to something, it has only one root essentially, right? So let's go back to this one here now. Right? So forgive the shape of this, the negative curves, right? Because the maximum point curves, because this tablet that I'm using is still not perfectly used to it as yet, right? So let's do this one here. Right, so for this one, we want the nature. So feel free to pause the video at any point and try it for yourself. What is the nature of the vertex? Right, in this case, it is a maximum point because it has a highest point. The second one, we want the coordinates of the vertex. Right, so the coordinates of the vertex, the highest point, is touches here. So this is at x is 5, right, so the coordinates of the vertex is x is 5, y is 0. Right, so x is 5, y is 0, 5, 0. Good. The third one is the coordinates of the y-intercept. Sorry, y-intercept. Right, again, the y-intercept is here. So that is on the y-axis. So x is 0 minus 9. And again, the y-intercept alone is negative 9. Number 4, what are the coordinates of the roots? Coordinates of root. Now, in this case, this is a similar graph to this one in that the graph only touches the x-axis here. Yeah, so that's, we only have one root here, and the coordinate of this root is again 5, 0. The root and the vertex is the same in this one as well. And number 5, last one, we want the axis of symmetry. Axis of symmetry. Good. So we just draw the line of symmetry to cut this curve in half. I notice it passes through 5 on the x-axis. So x is equal to 5 is your axis of symmetry. Right? Now, the last two underneath here now. Take this in for, feel free to pause the video for 10 seconds and try to figure out what is the difference between this and the other graphs, all the other graphs above. Right? And if you pause it, what you will see is that this graph has what we call no real roots. So this is a minimum point graph, right? Minimum point. The vertex, the coordinates of the vertex are, so let's do this so quickly because time running out. The coordinates of the vertex are 2, if our number here, 2, 1, right? The coordinates of the y-intercept, coordinates of y-intercept are 0, 12. But for the roots, there are, this is what you say for this one, there are no real roots, right? Because the graph doesn't pass through the x-axis, yeah? And the last one now is for the axis of symmetry, which I'll shortcut for this here, AOS, axis of symmetry. When you draw a line of symmetry, you notice it passes through x is equal to 2. Yeah. So what I'll do, I will leave you all with this one here to think it through. And in the comment section, feel free to post what your answers are for this one here. Right. So again, if the graph does not, if the parabola does not pass through the x-axis, this is what we see. There are no real roots. It's not that they don't have any roots, but we don't want to get into that kind of match right now. But there are no real roots when it doesn't pass through the x-axis. So that's it for this class, and in the next session, we will be talking about the much feared vertex form or completing the square. So until then, stay safe, everyone.